and then we'll get started. So today we are fortunate enough to have Nina Torgunakova, sorry, who's a front-end engineer at Evil Martians, which is a product development consultancy. She's passionate about continuous learning. She enjoys sharing her knowledge as an author and frequent public speaker. She loves breaking down complex concepts into practical, actionable insights for fellow engineers. And when she's away from her keyboard, she enjoys lyrical dancing, learning new languages, and exploring new places. So without further ado, I'm going to stop sharing and turn it over to Nina.
Thank you, Lexi. Just 1 second and I'll start sharing. Okay, I shall go right now. So I'm really excited to join this amazing community today. And let's talk today about smart and tiny nano stores and how we can make front-end simpler by using them. As I was introduced, I'm Nina. I work at Evil Martians. It's a product development consultancy, and we are working with both large clients and startups, and we are also actively developing our own open source products. And when I just started learning development a long time ago, I was attracted by frontend because I could quickly see the visualized result of my work. I think many of us can relate to it. And there was a time when learning 3 tools for frontend was enough. The developers learned HTML, CSS, and JavaScript, and then we were able to create the front part of application of any complexity. But the world of web development has changed very quickly, and now the front end is different. That's what we have now. Now we have a whole lot of different tools, different package managers, build tools, preprocessors, and so on. And all of this started when we got frameworks. And we believed that frameworks will make development simpler for us, and they will be able to significantly increase the speed of writing code. And we expected it to bring us more convenience. But what we eventually received? The modern web development world is becoming more and more complex every year. But the most important problem is that people actually suffer from it. And first of all, the developers suffer from this. We suffer from this. And we are the first ones to face difficulties from our own developments. We are drowning in frameworks, in different libraries and utilities for frameworks, and for what? Very often just for obtaining the same results as years ago, but with the illusion of better convenience, which frameworks promised us, but then deceived. Today, to build something sometimes very easy, we often need to do a lot of different actions. For example, when I start a new project, I need to set up environment, to set up testing environment, add JS preprocessors, CSS preprocessors, and so on. So our life didn't become much easier with this. The next type of people who suffer from increasing complexity of the web development world are users. And if users suffer, we know that everyone else will suffer later, including developers. And the thing is that the average size of web pages is constantly growing up. And if in 2012 it was about 800 kilobytes, then 2 years ago the average web page size was already more than 2000 kilobytes. And the more code and the more complex tools, the larger the web page size. And the thing is that the slow load times is actually a huge problem for people. How long do you usually wait for a site to load before you look elsewhere for the information that you need? Statistics shows that saving every second is important in order to not lose the user. And finally, from the complexity of web development world suffers business. And not only because of losses of users, not only because developers are burning out, again, because sometimes to do the same amount of work, we spend a lot of our resources. So let's add the necessity of supporting the old legacy code and the maintenance need. And it already takes business to wait more time and spend more developer resources on the very same tasks. As a result, business has to waste both time and money, which may have depressing consequences. So let's summarize. Everyone suffers from growing complexity of web development world. Users, developers, business, and it doesn't become really much better because the complexity is growing. So maybe we did something wrong. Maybe we need to make a step back and change something. Let's try to find inspiration in wise ideas from popular people in our community. And we can start with some suggestions from recognizable developers. Fold knowledge into data, so program logic can be stupid and robust. That's a quote from Eric Raymond, a well-known open source ideologist. In his book, The Art of Programming for Unix, he presented a number of approaches for minimalistic and modular software development, and the rule of representation was one of them. Let's try to apply this idea to the problem that we have now. The modern web development world revolves around frameworks. When we're working with some new tools, we usually check if these tools are compatible with our particular framework. And many libraries are developed purely for a particular framework. And the framework is now responsible not only for how we display information, but also how we process different logic, how we store data, and how we develop new business features. But the more work a component does, the more difficult it is to maintain, to change, and to test it. All of this can be imagined as a kind of space model, where in the center of our universe is a framework. But, you know, people used to believe that the Earth was the center of the universe and not the sun. And only after some centuries, people realized that they made a mistake. So what if we made the very same mistake by placing the wrong object in the center of our system? And we can also shift our focus and think that in the center of our universe is not framework, but data. If we apply the rule fold knowledge into data and focus on the data and not framework, then our model will change like this. The data in the center and everything else revolves around it. But what exactly do I mean by the concept of data? What is the well-known process in web development world when we store and manipulate some data? I'm talking about state management, which is the process of maintaining knowledge of the application data across its multiple parts. And here we use the concept of store as an appropriate place to save the application's data. So to move from a data center concept to a data center concept from framework-centric concept, we need to make stores smart, move them outside of components, and make them independent on a framework. Then the components can be stupid and responsible more for display than for logic. They'll just receive the needed data from stores, and that will be closer to our idea of fold knowledge into data. So we've figured out this important idea. We want to fold knowledge into data outside components and inside stores. Let's remember it and try to find more inspiration. Bad programmers worry about the code. Good programmers worry about data structures and their relationships. This is a phrase by Linus Torvalds, the lead developer of the Linux kernel. He emphasized the idea that before writing code, it is necessary to work out the architecture of the data and the relationships between data structures. So let's do this. And a very popular approach in state management, both now and years ago, is to store state in a single global object. But with this approach, for any change inside the global object, all components will need to call a selector function. And our chunk may contain data that is not used by the components on a page. It's a workable approach, but it's not very optimized. What if we try to improve the current state management architecture a bit and optimize it? And here we can refer to the idea of reactive programming and the observer pattern. The observer pattern has multiple entities called subscribers, which register themselves as observers, and they're notified and updated automatically when the state of an observable object changes. To apply this pattern to state management, observables must be the stores that store data, and subscribers must be the components that receive the actual data. But we also don't have a strict restriction that there should be only one observable for the entire project. So instead of single and huge global object, we can create many small atomic stores, and each of them will contain only a specific piece of data. So components can subscribe only to a piece of data that they need. But in the real world, things are not usually that simple, and often we need to change the data based on changes in another data. So how to organize this logic? The solution here is simple. We want not only components allowed to subscribe to stores, but also allow stores subscribe to other stores changes. So that's when some data in one store changes, we will update the state inside another store. And then every store will be able to receive a needed updated set of data and change its own data based on this. So we'll have chains of reactive computations. Now we figured out two important ideas. First, we want to move logic to stores outside of components, so components can be very minimalistic. And otherwise, we also want to make stores small and smart. So let's go further. And the next phrase is not by a developer, but from a writer and famous aviator, Antar de Saint-Exupéry. And he said, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And this idea can be easily applied to development. Have you ever seen a user interface that has so many different features that you just got confused in them, and the important things just cannot be found? This is also about the fact that redundancy can easily ruin even a good product. When I was a beginner developer, I met the concept of state management when I wanted to do something really simple. Get a user's name from a server and use it in several components of my application. But when I started finding information about the concept of state management, the first thing that I found in Google was such a scheme, consisting of many different entities and complex interactions between them, which includes effects, reducers, selectors, services, components, and a number of other things to handle cases of different levels of complexity. Although in that simple case, all I had to do was to get a value from a server, put it inside store, and then use it in the components when I needed it. Only 2 actions and 1 store instead of a complex scheme and half of a dozen entities. The simpler and more minimalistic the process, the less is mental load, and less likely we will get confused in entities and interactions between them. And by this, I don't mean oversimplification. Albert Einstein once said, everything should be made as simple as possible, but no simpler. And this is true. While keeping the idea of a simple process, we should not forget about the more complex cases, and we should consider different developers' challenges. What kind of task it can be? For example, we may want to synchronize state changes between different browser tabs, or implement SPA navigation based on the state of our application, or we may want to resolve conflicts between different devices, or just make our application fully translatable to different languages. And this can be expanded depending on the project. So we need to find a solution to consider complex cases, but with a minimalistic approach to achieve the balance. First, we don't want boilerplate and redundant actions and entities for easy cases, but we also want some convenient way to solve hard cases with no mental overload. Okay, we have figured out something. That's enough. Let's recap all these ideas I have come up with. First, we want to move logic to stores outside of components. We want to fold application states inside smart stores. So our components will be stupid and robust. And we will just import these stores where we need them to components, and there will be no complex logic connected with data inside the component. The process should be minimalistic, but the stores should be smart. Since our stores will be atomic and not global, they must be able to react to changes in another stores by subscribing to their values. Thus, we will have chains of reactive computations and the ability to handle cases where some data depends on other data. 3, our state management process should be simple and minimalistic as possible. We don't want any redundant actions or entities. In the ideal, everything we need to do is create a store, get actual value by subscribing, and then set value when we need to change the state. That will be enough for easy case. And we should not throw out more complex development tasks from consideration. Despite the fact that we want to achieve simplicity and minimalism, our state management should provide convenient tools for implementing various features like synchronization, automatic translations, smart data fetching, conflict resolutions, and much more. Me and other Evil Martians were thinking a lot about what state management would suit all our requirements and solve all problems that bothered us. And we couldn't figure out. So we created our own tool that will satisfy our needs. It is called Nano Stores. Nano because its size is less than 1,000 bytes. And Nano Stores built around all the principles that I just told you about. But enough just talking about theory. Let's see how to use Nano Stores in practice. Now we'll create a small online catalog. It will have 2 pages. The first is a catalog with different Nano products. There is a header with the title of a page, a search bar, and a list of products. We can add each of the products to a cart by clicking on a button inside the product cart, and there is also a button at the right top corner to go to the shopping cart. And at the cart page, we also can see a header and the list of products that were added to the cart. So, how we'll do it? First, we need to create a simple store that is called products, where we will store an array with the products of our catalog. To do this, we create a file that's named state.ts. and we import the atom function from Nano Stores library, and we call it, passing an array of objects as a first argument. This will be the initial value of the store. In TypeScript, we can optionally pass value type as a type parameter. That's what happened here in Angular brackets. So we make this store exportable so we can import in our component. Our component is called catalog.tsx, and here we import this item store. And here in this demo, I use React, but in fact, the framework doesn't play a significant role because we want to abstract from them as much as possible so that all the logic will be in our stores, in our data. So from Nano Stores React library, I only import the useStore hook. This is a hook to get the storage value and re-render the React component on store changes. This functionality is also implemented for most modern frameworks such as Angular, Vue, Lead, React, and others, as well as for vanilla JS. So it's just a hook to make our stores work with any framework that we want. So here we just invoked this useStore hook. So we received our list of products, and that's enough to just display this catalog. So for now, all the process was we created a store with some initial value, then subscribed to it in a component, and then we just displayed the elements of the array in our interface, and all through simple one-line commands. Now let's add a search bar to our catalog page. We will need a search bar component in which we will type the name of the product. And the table will be updated automatically, filtering all products by this value. To do this, we will create another atom store in a state.ts file, in which we will store the value that users type in a search bar. Initially, the search string is empty, so we can put an empty string there. Then, just as we did the last time, we import the created store into the search bar component and subscribe to its changes using the useStore hook. In the HTML input element, we will bind its value attribute to the value of the store. And on the onChanged event, we will be updating the value of the store. In this way, every time the user enters a new value in our search field, the value inside the store will also change. In order for the list of products in our catalog to update automatically, depending on what we typed in the search field, we will create a store, the value in which will depend on the value in a search bar store. So to do this, we import the computed function from a Nano Stores library into state.ts file and initialize the derived store. Here we call the computed function and pass two arguments to it. The first of them is an array with the stores on which our filtered products will depend on. So in our case, there is search stream store and the original store with products, and a callback function that will be called on changes in the stores that were listed in this array. In this function, we'll just filter out products by the current value in a search string. Next, just like we did it with the Atom product store, we import the computed store with filtered products, subscribe to it in a component, and display its elements instead of the previous Atom store's elements. So we just basically substituted the stores. And here's how it looks now in the interface, where we type some value in the search field. The products in the catalog are filtered using chain of reactive computations. And okay, this is good, but in the real world, we usually don't store the objects for a catalog in an array on the front-end side. We usually get them from server. So let's add this functionality to our example. And here we have a tool in Nano Stores ecosystem, which has a smart fetcher for Nano Stores. It is called Nano Stores Query. And this tiny data fetcher for Nano Stores allows us to automatically fetch data from server and save it inside Nano Stores. First, to use it, we should define the context. It allows us to share the default feature implementation between all fetcher stores, and also allows us to make simple mocks in tests and stores. This store is transport agnostic. We can use GraphQL, REST, or plain fetch, or anything that returns promises. When our fetch is successful, we just read and parse the data using JSON function. And second, we create fetcher store. Create fetcher store returns the usual atom from Nano Stores, which is reactively connected to all of the keys listed in the first arguments. In our case, fetched products is independent of other stores, so we can just specify a simple string as its key. But if it was a computer store, instead of a string, we could pass the list of stores our new store is dependent on. This store with smart fetching is used in the component in the same way as the previous stores, with just a slight modification. Subscribing with use store will not only return data, but also a Boolean flag loading, which is indicating whether the data has finished its load. And based on this flag, we can display a spinner if the loading value is true. And if it's false, then there should be some data in data content. And if there is nothing in content, it means that some server error has occurred, and we can display this error. So here we just see a spinner when it's loaded. And then when it's loaded successfully, the data content will automatically change, and the spinner will be substituted with a list of products that we received from server. Fetcher stores have a wide range of optimization options. Under the hood, we use a built-in catch, and when it's revalidated, fresh data is pulled up. We can customize the revalidation settings, and it will allow us to automatically refetch the data when browser window is refocused, when the network connection is recovered, or just in some specific interval. And all of this can be done with simple refetching settings at the moment when we create fetcher store variable. Okay, let's add the last feature to our example. Now we have 2 pages in our small project, and it will be nice if users can understand which page they're currently on. So let's add a display of a page title and header and in a document title of our HTML document. So we will change it every time when user navigates from one page to another. To achieve this, we will use Nano Stores router, a tiny URL router for Nano Stores, and that's another tool from our Nano Stores ecosystem. So Nano Stores router provides the ability to create a router object and treat it like a regular store. Let's create this router store. We need to import the function create router from Nano Stores router. And then we initialize our router store by calling create router with an object, which is just the correspondence of route names and their patterns. Patterns can be written as regular expressions or just paths as strings. Then we will create a router component, which we place inside the main component of application. In this component, we subscribe to the router, so it will take the actual page route whenever we move from one page to another. Then, according to the condition, depending on route inside router, we will display one page or another. For example, if the route is catalog, then we display catalog page. If it's a card, then we display page with card. The card page is built exactly the same as the catalog page. It's just binded to another store for cards with the items that we previously added. So we want to create a header component in which we will display the title of a page we are currently on. So we create an atom store with a header name, and initially it will be just an empty string. Then we subscribe to the router change directly. This syntax also works. And each time when we receive new value, we will set the corresponding value of the header name store. This also works with document titles, title of HTML document. We'll set it the same and at the same time. All we have to do now is just subscribe to the header name atom store inside the header component and display its value. So when we go to the catalog page, the header and the document title will be the image both. And when we go to the card, it will be like on the image below. The router listens for events both and clicks on the native HTML links and on the browser's back button. Only last thing. On this slide, there is all code of Nano Stores regarding atom stores, which is just 84 lines. It's an open source tool, and I believe that if you understand how your tool is working and you can check and fastly read it in a few minutes, that's a great benefit. So no more black boxes and obscure labyrinths. We believe that moving to easy to understand processes is important and necessary. So next time when you realize that you need to store a state in your application, choose some minimalistic approach. And just in case, Nano Stores are always ready to help you with it. Thank you for your attention. And if you have any questions, I'll be glad to answer them here or on my social media.
Wow, thank you so much, Nina. That was fantastic. Great presentation, great demo. Thank you.
Thank you.
So I'll reshare my screen real quick, and we have some time for Q&A. And I see there's a bunch of questions in the chat, so we will get to that.
Let me just open the chat.
So share. Okay. So first question. First question from Violina. How easy is it to migrate an existing project with ZooStan to Nano Stores?
Oh, I think it depends on the size of the project. I migrated to Nano Stores, an existing project with not ZooStan, but some other state managers. It was actually really depend on the size of the project, because if there are a lot of different fields, it's like I won't be lying, it can be hard, it can take time. But if it's just not that big project, migrating is not that hard usually. Sorry, can you hear me?
Hi, yeah, sorry about that.
Yeah.
I just had to unmute myself. Sorry. Great, thank you. Next question, also from Violina, is can Nano Stores also be used in React Native projects?
Actually, I haven't tried this with React Native, but as it works with plain JS code, you always can try.
We'll have to do some research into that. Next question is from Sophia. Is there a good resource or book that you recommend to find out more?
I don't remember like good books on state management particularly. So I guess it's just about reading fresh articles that are released on more new state managers, because a lot of state managers are appearing. Some ideas of them are good, some ideas are not that good and still use some global approach. So I think it's just important to stay in loop and follow different LinkedIn sources that publish fresh information.
Great, thank you. Yeah, everything changes so quickly in the world of development these days. So following as many different people is always a good bet.
That's true. Yeah.
All right, we have one last question from Aaliyah in the chat. Does Nano Stores handle TypeScript support and type inference? Oops, did we lose Nina? I think we lost our speaker, but that was a fantastic presentation. If she doesn't pop back on, I'll have to message her and thank her again. But thank you all very much for coming today. I really appreciate it. And it was great. I learned so much. And sounds like everybody else did too. So yeah, she dropped the GitHub link to Nano Stores for people to check out. So definitely I'm gonna head over there in a few minutes and see more about it. So yeah, thank you all for coming.